My stance on global warming is so-so. I feel like I should believe it, but I don't. I'm somewhere in between where I see all the evidence, I believe it all, but I don't believe that it could lead to this much warming. The poles, in my opinion, will always be there. There'll always be ice. Florida won't get covered up. I mean, people predicted that Florida, like the Caribbean islands down there, would be flooded, 5 years ago. They're still here. According to the EPA, United States Environmental Protection Agency, greenhouse gas concentration in the atmosphere will continue to increase unless a billion tons of our annual emissions decrease substantially. Increased concentrations are expected to increase Earth's average temperature, influence the patterns and the amount of precipitation, reduce ice and snow cover as well as permafrost, raise sea level, increase the acidity of the oceans, increase the frequency, intensity, and or duration of extreme events, shift ecosystem characteristics, increase threats to human health. According to NASA Global Climate Change, many observations of global warming have been observed, such as glaciers have shrunk, ice on rivers and lakes is breaking up earlier, plants and animal ranges have shifted, and trees are flowering sooner. Effects that scientists have predicted in the past would result in global climate change are now occurring. Loss of sea ice, acceleration sea level rise, and longer, more intense heat waves. According to globalclimatescam.com, in 2014 there was record ice, record snow, and record cold. In 2014 there was record sea ice in the Arctic. In fact, Global Warming Expedition got stuck in it. Arctic sea ice has also made a nice comeback in 2014. The Great Lakes had record ice. Lake Superior only had 3 ice-free months in 2014. You would think that in the hottest year, even that ice would be melting, like Al Gore said. In 2014, record snowfall in many areas. Remember when they said that global warming would cause snow to disappear and their children wouldn't know what snow is? In 2014, we saw all kinds of cold records. Remember the polar vortex? You'd think that'd be breaking all kinds of heating records in the hottest year.
Heat in minus heat out equals change of heat. And the heat coming into the Earth all comes from the sun. The heat going out to the Earth is emitted by the Earth itself as infrared radiation out to space. And the CO2 slows down the emission of heat to outer space. So really it's the sun comes in, warms it up, but the CO2 prevents the heat from getting back out, and that makes it warm up. It would be very hard to bring them down because when you burn coal, oil, and gas, of course, the reason why we do that is that there's energy stored in the bonds of those hydrocarbons. So the reason why we set them on fire in the first place is because energy is released when we do that. And in order to sort of grab the loose inorganic CO2 molecules out of the air and force them back into some sort of solid or liquid or something, that actually uses energy. So you could go, suck CO2 out of the air and make it into something that you could bury, but it would require a huge amount of energy. And if you had a huge amount of energy, where are you going to get the energy? So I suppose we could burn coal, but then we're actually losing that battle, right? Because we're burning coal that makes CO2, and then we're trying to use the energy to suck the CO2 back out. So it is possible to remove CO2 from the air, but it is very, it takes a lot of energy. And if you have a lot of energy, just use it to keep the lights on, and that way you don't put the CO2 in the air in the first place. Yeah, it's even less than that, 0.04%. But yeah, I mean, it's the most of the air, so 99% of the molecules in the air are N2 and O2, so nitrogen and oxygen. Mm-hmm. And those molecules are transparent in the infrared, so the infrared goes right through 99% of the molecules. It's only the molecules that have 3 atoms or more, and that would be CO2 and H2O, and then a bunch of trace gases. Those molecules absorb almost all of the energy that is absorbed by the atmosphere. Almost all of it is absorbed by CO2 and water vapor. So even though it's only a tiny part of the atmosphere, it's a huge part of the absorbing part of the atmosphere. And this is from measurements. This is something you can just do in a laboratory, shine infrared light through different gases and measure how much heat is absorbed. And if you shine them through oxygen or nitrogen, it just goes right through. But if you shine it through CO2, the CO2 absorbs the infrared radiation. So it isn't, I mean, you can say, well, it's only 0.05%, but imagine if the air was 0.05% carbon monoxide instead of carbon dioxide, we'd all be dead, right? Because 0.05 of CO would kill you. Mm-hmm. So, you know, a small percentage doesn't mean it's not important. Yeah, it's right up there. It's about 1/10 as much as the amount that comes from coal, oil, and gas. So yeah, it definitely adds to the CO2. When you cut down trees are made of carbon, or you know, plants have a lot of carbon in them, and the carbon in the trees, if you burn it or if you let them rot, goes into CO2. But the rate at which we're cutting down, and it's not us, right? It's Brazilians, are cutting down the rainforest is only about 1/10 of the rate at which we are burning coal, oil, and gas. And even that's not mostly us. I mean, China burns more coal, oil, and gas than the United States. But between China and the U.S. and Europe, you know, among us, we're burning something like 10 times as much carbon every year as the amount of rainforest that's being cut down. Yeah, well, the main thing, pretty much the only thing we can do about it, is to use energy that doesn't involve setting carbon on fire. So, you know, whenever you burn carbon, it makes CO2. And so nuclear power, wind power, solar power, hydropower, any of those kinds of electricity don't involve setting carbon on fire. Of course, the other thing we can do, which is even cheaper than all those things, is to make more efficient houses and buildings and, you know, air conditioners and cars and everything that we use that uses energy. If we could increase the efficiency of those things, then we would need less energy to begin with. So you want to first do the stuff that saves you money, like better roofs and better windows and better air conditioners and better furnaces. And then with the money that you save from all of those things, you want to use that money to roll out non-carbon sources of energy like nuclear, hydro, wind, and solar.